On June 13, 1943, an ominous black cloud rose above the English coast. Moments later, a powerful explosion lit up the night sky. To the British people, this must have been the largest firework they'd ever seen. But it was no celebration. In fact, it marked the birth of modern missile warfare. This was the first V-2 rocket attack on London, and over the next few months, 6,000 Londoners would be killed or injured by these mysterious new weapons. But what was the V-2 rocket? Where did it come from? And how did it change the world? As always, you're about to learn some really interesting stuff. But before we start, remember to subscribe so you don't miss any more of our videos. The V-2 was one of the most advanced weapons of its time, but it was hardly the first ballistic missile. In fact, as early as 1573, a Polish artillery engineer named Konrad Zuse had designed a rocket-propelled. However, the V-2 was the first human-guided missile to be delivered in mass. It was also the first to use a liquid fuel, which gave it a greater range than solid fuel rockets. Furthermore, its advanced construction allowed it to be reused many times. Finally, although not the first, it was arguably the first weapon of mass destruction, capable of inflicting great damage on entire cities. Development of the V-2 began in 1932 under the direction of the German Air Ministry. At this point, the idea was merely to create a long-range, large payload delivery system that could be used against enemy troops on the battlefield. However, after Hitler came to power, the military applications of such a weapon soon became apparent. The Werfer II, as it was originally called, was put under the control of the army instead of the Luftwaffe, and given the designation V-2. Most of the development work took place at Peenemünde on the island of Euston in the Baltic Sea. A team of around 1,500 engineers and scientists worked under the leadership of the brilliant but troubled Wernher von Braun. Von Braun had been fascinated by rockets since childhood. His father had worked for the Prussian artillery, and by age 8, he had built his own rudimentary rocket-propelled vehicle. He studied mechanical engineering at university and eventually joined the army, where he continued to experiment with rockets. One of his designs was even used in World War II as a smokescreen. However, after the war broke out, he became increasingly disillusioned with the army's short-sighted policies, and in 1937 he was given permission to set up his own rocket testing facility. Here, working in secret, the team managed to produce a number of successful prototypes. The V-2 was far from being the first rocket to reach outer space. Indeed, as early as 1926, the Russian physicist Friedrich Sander had calculated that a rocket with a mass of 260 tons and powered by 3,000 engines would be able to break free of Earth's gravitational pull and reach outer space. By 1937, von Braun and his team had built a much smaller rocket capable of carrying a 1-ton warhead to an altitude of 120 miles. By 1941, they had developed a larger version capable of reaching targets at least 200 miles away. This was far beyond the range of conventional guns, bombs, or even aircraft, and so the Werfer II was born. It consisted of 2 stages linked together by a hollow central section. Both stages were powered by liquid oxygen and alcohol, giving them a top speed of 3,500 miles per hour and a range of over 200 miles. Although just under 19 feet tall, it weighed nearly 14 tons and carried a 2-ton warhead. The first stage engine ignited at the base of the rocket while it was still on the launch pad. When the rocket took off, the burning propellant pushed the 2 stages apart. Once the first stage was empty, its engines automatically shut down and it fell away. The second stage then continued on its way until it reached its target. Its engines would burn for just over 3 minutes, during which time the rocket would cover about 90% of its total distance. Once the second stage reached its target, It would release its warhead, which would detonate on impact. In order to keep the cost and development time down, many of the components were taken from other weapons, including the fuselage of the Heinkel He-111 bomber and the BMW motorcycle engine. However, there was only one problem. The team at Peenemünde were unable to produce enough engines for all the rockets. This is when the head of the German armaments ministry stepped in. Hitler was furious with the slow progress, and he wanted the first V2 rockets deployed in September 1942. At this point, von Braun had doubts about the weapon's reliability, not to mention its safety. But he was overruled, and the first batch of 500 rockets were sent to France, where underground launch facilities were hastily constructed. The first test launch took place in October 1942. It failed. A second attempt in November was also a failure. However, Hitler was becoming increasingly impatient and demanded that the first strike on London take place before Christmas. So von Braun and his team went into overdrive. They quickly built a third prototype and tested it on December. This time it worked, and on December 1942, the first V2 landed in southeast London. As we already mentioned, the bomb had been designed for battlefield use, and there was no real way to steer it. It simply flew in a straight line for the distance specified during its manufacture. This made it virtually impossible to intercept. Not that the British didn't try. Soon after the first attack, they began dropping massive amounts of mines into the sea in the hope that the V2 would hit one of them and explode. They also built huge radar systems capable of detecting the V2's heat signature. Although these measures helped to some extent, the Germans were able to continue launching their rockets. In total, between March 1943 and March 1945, the V2 was fired 3,896 times. Of these, only 57 failed to explode or were shot down. Nearly half of the rockets hit London, but the rest were fired at Antwerp and several other cities. In all, the rockets killed around 6,500 civilians, most of them women and children. But the true death toll could have been much higher had the attacks not been so silent. You see, the V2 produced no sound whatsoever, not when it took off, nor when it exploded. This is because the rocket's engine was sealed inside a pressure vessel and burnt its fuel in a closed cycle. All that could be heard was the whistle of the wind as it sped through the air. This not only made the rocket extremely difficult to detect, it meant that those living in its path had no warning that it was coming. Many people were asleep when their street was suddenly lit up by a bright white light, followed by a mushroom cloud of smoke. Others were taking shelter in the tube stations when the rocket hit the ground just above them. The first attack caught Londoners totally by surprise. No one knew what to do. People cowered in their basements, listening to the distant rumble of falling debris. Many more ran towards the countryside, believing that it would be safer there. But it wasn't. That's because the V2 was not the first rocket to travel through the atmosphere and reach the upper reaches of space. In fact, both the United States and Russia launched similar rockets earlier that year, as part of their efforts to achieve orbital flight. This meant that the V2 was traveling at a speed and altitude that had never been achieved by a manned vehicle. It re-entered the atmosphere at an incredible speed of 25,000 miles per hour, producing an intense fireball. So why did the Germans choose silence? Well, it may have seemed like an advantage to the designers, but in reality, it was pure chance. You see, the V2 was supposed to be fitted with a siren that would emit a loud screeching sound during its descent. However, in the end, this proved too difficult to build reliably, and the feature was scrapped. After the war began, the Germans tried to counteract the V2s with their own rocket program. They even briefly succeeded, but this was nothing compared to the sheer terror inflicted by the V2s. The British had little idea that their worst nightmare had actually been designed by the very scientists they were trying to fight. By the end of the war, some 70,000 people were employed at Peenemünde, making it one of the biggest industrial complexes in Europe. However, as the war turned against Germany, the Allies began launching bombing raids on Peenemünde, killing hundreds of scientists and destroying years' worth of research. In 1945, the Soviets invaded and occupied Peenemünde. Most of the rocket team fled west, but the Soviets caught up with them and arrested 58 of the scientists, including Wernher von Braun. They were charged with war crimes and taken to a prison camp near Nuremberg. However, following a series of show trials, most of the charges were dropped and von Braun and his colleagues were set free. He was offered a job by the US government and spent the next 4 years helping them develop their own rocket program. In 1950, he became director of the development of the American Jupiter rocket and played a key role in landing the first satellite in orbit and putting the first astronaut into space. So, there you have it. The Nazis created the world's first ballistic missile, but they couldn't hit the broadside of a barn with it. If you enjoyed this video, make sure you check out our video on Hitler's UFO obsession. Thanks for watching.